Okay, so to start off, you just highlight the important information in the question, which is the amount of moles and NaCN. Then you can write an equation of NaCN, which produces Na plus and Cn minus. Then you are going to check for hydrolysis, which is just checking to see if either of the products react, or sorry, the products react with water. So first you check Na, and Na is in group 1, which part of the rules of hydrolysis is that members of group 1 or elements in group 1 cannot react with water. And then for Cn, it is a conjugate base of a weak acid, so it can react with water, and that is just part of the rules as well. So then what you're going to do is take Cn and write an equation of it reacting with water. So it'll be Cn minus plus H2O equals, and you're going to, or produces, and you're going to use the equilibrium symbol, HCN plus OH minus. Next, you're going to make an ice chart and use the information that was already given in the question. So you know that there's 0.083 moles of Cn, and you know that you have to omit water, and then it starts out with 0 HCN and 0 OH. Then you're going to write minus X on the reactant side and plus X and plus X on the product side. Then you'll put those two together and write 0.083 minus X and X for the equilibrium. Then you're going to write an equation for Kb, which Kb equals the products over the reactants. So you'll put HCN times OH over Cn, and you don't include water in this because you omit it. And we need to find the Kb, and we have the information to do so because we were given Ka in the equation. So you can use the equation Kb is equal to Kw over Ka to solve for the Kb, and Kw is a constant, so you already know that, and you were given Ka in the equation, so you can just plug those into the formula and then into the calculator, and it will give you the Kb. So just put those into the calculator, and it is 1.0 times 10 to the negative 14, and then you divide that by 4.9 times 10 to the negative 10, and that will give you your equilibrium, or sorry,
I'm having trouble hearing you.
that will give you your Kb. So it's 4.9 times 10 to the negative 10. So the answer is there, and we'll write it down there, just including 2 decimal places. So 2.04 times 10 to the negative 5, and then you can put that back into your Kb equation or equilibrium equation, and it'll be 2.04 times 10 to the negative 5 is equal to x times x, or also x squared, and then 0.083 minus x. Now it's harder to solve it this way because you have to use like the quadratic formula and stuff. So you use the 100 rule to see whether or not you can take out the x on the denominator, and for the 100 rule you use the 0.083 and divide it by the Kb, and if it is above 100, then you can take out the x from the denominator. So you do the 2.083 divided by the 2.04 times 10 to the negative 5, and then that will give you a number, and this one is way over 100, so you can take out that x, which will make it much easier to solve. So the next thing that you will do after you take out the x is to multiply the KB value by the denominator to get rid of it on the right hand side. So you can put that in the calculator. So 2.04 times 10 to the negative 5 and then you multiply that by the number on the denominator here, which is 0.083, and that will give you a new number, which you will keep on the left hand side. Okay, so then you take that new number and you square root it, because you have x squared, the two x's from the numerator, and that will give you x, and x is also equal to OH minus, as you can see from here. And you can use that to solve for POH, which is negative log times OH. So negative log times 1.3 times 10 to the negative 3, and put that in the calculator. So negative log times 1.3 times 10 to the negative 3, and that will give you 2.88, and then you can solve for pH by doing 14 minus 2.88, and that will give you the final answer of the pH, which I believe is 11.11. Yeah, and that seems correct because it is a base, and bases are pHs are over 7.